In 2009, two researchers ran an experiment. They took everything we know about the solar system and calculated where each planet would be in 5 billion years. So they made up some so, some simulations, and they keep the exact same hit except for one, which is the distance between the sun and Mercury is decreased by 1 millimeter. Shockingly, in about 1% of their simulations, Mercury's orbit changed so drastically that it could plunge into the sun or collide with Venus. And in other in other simulations, Venus will cause a destabilization in the inner solar system. This goes to show that the solar system we know is much less stable than it actually seems. So, astrophysics name this thing as the n-body problem. While we have equations that can mm, that can calculate two of the motions, our analytic tools fall short. It is actually important to write down all the terms in the formula. But the thing is, some of the formulas are too much. We cannot write all down in one. The issues of the antibody systems, thanks to Isaac Newton, we can set up to describe the gravitational force between each planet or even stars. So, in these questions, we're faced with a mathematical construction. For each unknown, there must be at least one question that independently describes it. Initially, a two-body system prepare for position and velocity that equals of motion. However, there's a trick. Consider these related positions and velocity of two bodies, which makes a respective center of gravity, which they keep in touch, and make and with three or more orbiting objects in the picture, everything gets a little bit messier, as some of them don't respect the center of the gravity. We are left with more unknowns than equations to actually solving the unknowns. There are simply too many to be untangled into a general solution. But what does it actually look like for objects in our universe to move around according to analytic unsolvable equations? A system of three stars, like Alpha Culture, could come crashing into one another, or more likely get flung out of their orbit, or or have have collisions that would shock everywhere. Almost in every possible case is unpredictable on long time scales. Each has an astronomically large range of position in the velocity. But give us so we have a little bit of an equation. We have two same elements. Two that start the same, has the same elements we need, and has the same results. But if you change one one tiny thing at the elements, they will suddenly have a different result. They will change it to something else, not like the old ones. By approximately the solution will increase powerful sessions. We can more confidently predict the motion of n-body systems on a long time scale, and if one body in a group it exerts no significant force on the other two, the systems behave with very good approximations at a two body restriction called restricted free body system. It provides asteroids to don't hit Earth, which we know about gravitational. As for the solar system, you'll be happy to hear, but stay we'll stay secure for at least than millions of years after, unless a star comes and breaks all the rotation of star of planets around the solar system and the sun. So that's my speech. I would like to end.